Okay, here's the solutions for the Unit 3 Activity 8 practice assignment on intersections of lines. So it's about a school fundraiser to finance the athletic department, and it involves selling greeting cards, which is actually a fundraiser I would totally buy. Okay, so the school is going to sell the greeting cards for $25 for a pack of them. It doesn't say how many's in a pack, but it doesn't really matter. Okay, so that's one thing we know. That's one situation. So they're selling them for $25 per pack. So we could write an equation for that. It's basically there's no y-intercept. They're just making $25 every time they sell a pack of cards. So if they pack of greeting cards. So if they don't sell any greeting cards, they don't make any money. So I don't know if you want to just use y's and x's, or if you want to use like, I don't know, letters to represent stuff. I mean, I don't know. We could use like a C for cost, I guess, or M for money, whatever you want. So I'm going to say C equals $25 per greeting card. So I'll just say that, or per pack. Well, I'll just say a G. So 25G. Okay, so that's my equation for that, because 25 per pack is like my rate of change, my slope, and there's no initial value. I'm not charging an upfront cost. Okay, so I've got one situation figured out. Next one is our costs for our school. So it looks like we have to pay $300 up front, but then only $13 per pack of cards. So we're definitely going to make a profit, but because we're selling them for more than $13, but this $300 upfront fee that this company is charging us, we have to make that amount back up, since that's like a amount that we'll have to pay. So if I'm going to use the same variables, I would say the cost of our cards are going to cost us $13 per pack, so 13G, plus $300. Yeah, so that's how much we're going to be paying. So every time we buy a pack of greeting cards, we pay $13, and then we pay that one-time fee of $300. Okay. So now we've created the two equations that we need to represent each situation. And we kind of said C was equal to the money in dollars, the cost or whatever. And then we said G was equal to a pack of greeting cards. I feel like I don't have great math form right now. Like, I don't know, depending on what school, what teacher, everyone kind of expects a different thing from you, which is a bit confusing. But you know what? That's life. I feel like that's like normal in the world. So I just remember my high school teacher was like super formal. So they always wanted me to write, let C represent the amount of money. Maybe, is that good? The amount of money we earn or we have to pay. I guess it kind of is slightly different. And then let G represent the number of greeting card packs. Okay, we should be formal. Might as well, right? Okay, so we got our equations, we defined some variables, and now it says that we need to find when we're going to break even. So we want to graph the two equations on the same set of axes to determine how many packs of greeting cards we have to sell so that the athletic department can break even between the costs and the profit. So, yeah, that would be good to know, right? I'm just going to scroll up because all I care about is the equations, really. Okay, so I'm going to make a grid, and I only really care about quadrant 1. So, oh my gosh, like I thought in Notability, if you like hold down on it, it makes a straight line, but I'm using Explain Everything, and I don't know, I don't use that as well. I like Notability, but I can't seem to record on it. Okay, so there we go. So I'm going to use my Y variable as cost or money, I don't know. And then my X variable is going to be packs of greeting cards. And what should I go up by? So I want to make sure I hit the point of intersection. I don't really know where that's going to be, because you don't want to only like go up to 5 and then our lines haven't crossed yet. So might go up by like 5, 10, 15, 20, I don't know. 2, 4, 6, 8, 10, 12, 14. I have like a massive graph that I do here. So I think, I think maybe I could go up by 2s. 2, 4, 6, 8, 10, 20. Yeah, you know what? I'm just going to go 2, 4, 6, 8, 10. I just can't write that small. 2, 4, 6, 8, 10. 2, 4, 6, 8. Oh, 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. 2, 4, 6, 8, 40. 2, 4, 6, 8, 50. Like, there's definitely, like, I would think they got to break even before 50. Okay. And then for cost, we have to figure out what we need to go up by. It's like a little bit tricky. And if you're thinking, I have no clue what that's, you're just super clueless on like what you should be going up by, sometimes maybe it's helpful to draw a table of values. So unfortunately, it's going to take up my graph area, so I might erase this after, but I could make a little like greeting card cost table and just kind of go up by 2, like 0, 2, 4, 6, 8, 10. Kind of make a table of values for each one, just so like maybe it'll help me make my graph a little easier. 0, 2, 4, 6, 8, 10. Okay, so let's start with the red equation. If I sell 0 greeting cards, I'm making $0. And if I sell 2, then 25 each, so 25 times 2 is going to be $50. If I sell 4, 25 times 4 is going to be $100. 25 times 6 is going to be $150. And once you see the pattern, it's going up by 50 every time, and just fill in the rest. 200, 250. Okay, so I made a little table for that. Now I'm going to do the same thing for the other one, which is obviously the more tricky one. So if I sell 0 greeting cards, or sorry, this one's like your cost to buy them. So if I don't buy any greeting cards, I still have to, still going to cost me $300. If I buy 2 greeting cards, 13 times 2 plus 300 is 326. If I buy 4, 13 times 4 is 52, plus 300 is 352. If I buy 6 packs of greeting cards, 13 times 6 is 78, plus 300 is 378. And they're just going up by 26 every time, which makes sense, right? Because they would be going up by 13 every time, but since my G's are going up by 2, it's like double that. So then I can just do like 378 plus 26 is 404, plus another 26 is 430. Okay, so this just give me a rough idea of like, so like we haven't broke even yet at 10 greeting cards. So it's good we're going to 50. And I'm seeing, like I'm starting here at $300. I'm starting here at 0. So I'm definitely gonna want to start my graph at 0. At 10, I'm already at $430. And here I'm already at $250. So I'm thinking like, I want to be going up to, like almost $1,000. So maybe on my y-axis, I want to go up by, oh goodness, 10. Hundreds? No, that's crazy. 1, 2, 3, 4, 5. So that'd be not good. Maybe 50s? 51, 1, 2, 2, 3. Yeah, I don't know. Maybe 50s. So it'd be like 100, 200, 300, 400, 500, 600. I'm gonna go all the way to 1,000. I don't know. I'm gonna go to 900 apparently. So that's all I can fit. Okay, so now I've just settled on a scale, which I think is the hardest part of this question. Okay, so I'm gonna graph my red line first so I can get rid of that table because it's like totally in my way. So it's starting at 0, 0. And every pack of greeting card, it's going up 25, or every 2 packs, it's going up 50. So if I sell 2 packs, which is, this is like 2, 4, 6, 8. So if I sell 2 packs, that's costing me $50, or I'm getting $50. If I sell 4 packs, 100, 6 packs, 150. So it looks like I'm just, like I can just continue this pattern. So that's pretty easy. So I'm gonna erase my table here because it's right in the middle of my graph. So I'm going up like this. Okay, so I figured out the pattern. These are straight lines, so like whenever you get it started, it's pretty easy to keep it going. Okay, there we go. I could attach it with like a line if I want. I mean, I guess that, yeah, whatever. Line versus no line. We'll just leave it at a line. Okay, sorry, this is a long video. Okay, so my next table of values, so 0 and 300. So I know my initial cost is $300. So my graph's gonna start right at 300. And then it's gonna go after I sell 2 packs of greeting cards, or after I buy them, I guess. It's costing me $326. This is like a obviously less accurate graph than the other one. It's $326. So after 2 packs, we're at like $326, which is roughly halfway in between those. After 4 packs, we're at $352. So these are increasing half as fast almost. Not exactly, but kind of. After 6 packs, we're at $378. After 8 packs, we're at $404. After 10 packs, we're at $430. And maybe we just want to keep it going like this. You know what? It may be easiest to keep this graph going because it's really not an accurate graph since the numbers are like going up by 26s. That's kind of tricky. So if we still have 12 packs, we're at 456. Bear with me here, or feel free to skip through this part. It's gonna be a little boring. 12 packs, 456. And 14 packs of cards. Oh my gosh, we have so much to go. Okay, you would continue this, but like I already know the answers, so I'm gonna ruin it for you because I can't. I would just keep doing that. 16, 18, 20, 22, 24, 26. So if you just continue that, I'm gonna skip down to 24. So 13 times 24 plus 300 is 612. And then, sorry, 13 times 26 plus 300 is 638. Haha, that's kind of in my way. Sorry, I'm just gonna scroll up a little bit. 638. So once you're graphing it, I just totally gave this away, but 2, 4. So 24 packs will cost 612. So let's go up and find 612, which is like here. And then 26 packs will cost 638, which is going to be like down here. So you can see that the point of intersection, this is like a really rough graph, but it's going to be somewhere in between 24 and 26 because of where I'm plotting it on my graph. I'm gonna erase that. Okay, so, oh, it's a rough sketch here. So this graph's gonna look like this. So right from the graph, you can see where your 2 lines intersect, but since like I went up by 50s on my y-axis and 2s on my x-axis, it was harder to find the point of intersection because it turns out the point of intersection is at 25 packs of cards. So what I would kind of do in this situation is I would look and I would see that it crosses in between those. So then I might try to figure out, okay, what is the value? If I sold 25 packs, so like sub 25 into the equation. So 13 times 25 plus 300 is $625. Sorry, I'm like running out of space. $625. And in this one, C equals 25G, we're putting in 25. And we know 25 times 25 is 625. So like you can I don't know, once you kind of get close to the amount of greeting cards that you have to sell, you would maybe want to test them both out by subbing numbers into both equations and seeing when the cost is exactly the same. And it turns out that's happening at 25 packs of greeting cards. Yeah, so this one was kind of tricky because the numbers, like, you had to have a big scale and it's hard to fit all that in. But that's how I would kind of do it. I would just play around with my table of values, my numbers, manipulate my graph, because you want to get that point of intersection exact. So the point of intersection, I'm just going to call it the POI, point of intersection, is at 25 greeting cards and $625. So that means, let's interpret that the school will break even when they sell 25 packs of cards. So you have to sell at least 25 packs. Once you sell 25 packs, you've made zero amount of dollars, but at least you're not in the hole since you had to pay that $300 upfront fee. So that'll get you even. So then any other business beyond that, it's going to be pure profit. Well, not pure profit, but because you're still paying $13 for each greeting card. But anyway, but you're going to be making money. You're going to be making like $12 on each pack of cards. Cool. So that's how that works. Is that all the question asked you? Yeah. Determine when they break even. Okay. Sorry for the super long explanation.